Rust and C++ are both programming languages that are often used in systems programming and for building performance-critical applications. Each language has its own strengths and weaknesses, and the choice between Rust and C++ depends on various factors such as project requirements, developer expertise, and specific use cases. Here's a comparison between Rust and C++ based on several aspects. Memory safety. One of Rust's key features is ownership and borrowing, which ensures memory safety without relying on a garbage collector. The borrow checker enforces strict rules at compile time to prevent common memory-related issues like null pointer dereferences and data races. Memory safety in C++ relies heavily on the programmer's diligence. While modern C++, C++11 and later, has introduced features like smart pointers to help manage memory, developers still need to be cautious about manual memory management to avoid memory leaks and other issues. Concurrency. Rust has a strong focus on safe concurrency. The ownership system helps prevent data races, and the language provides constructs like ownership, borrowing, and lifetimes to handle concurrent programming safely. C++ has various concurrency mechanisms, including threads, mutexes, and atomics. However, ensuring safe concurrent access to shared data in C++ often requires careful manual management, making it prone to data races and other threading issues. Syntax and learning curve. Rust has a modern and expressive syntax. Its ownership system, while powerful, can be challenging for beginners. However, it aims to provide better error messages to assist developers in understanding and fixing issues. C++ has a more extensive and complex syntax, especially when compared to modern languages. It has a steeper learning curve, partly due to its long history and backward compatibility with older C++ standards. Ecosystem and libraries. Rust's ecosystem is growing rapidly, and it has a package manager called Cargo that simplifies dependency management. While it might not be as mature as C++'s ecosystem, it's actively improving. C++ has a rich and mature ecosystem with a wide range of libraries and frameworks. It benefits from its long history and widespread use in various domains. Performance. Rust is designed with a focus on performance, and it compiles to machine code, similar to C++. Its ownership system allows for zero-cost abstractions without sacrificing runtime performance. C++ is known for its performance and efficiency. It provides low-level control over system resources, enabling developers to write highly optimized code. Performance. Rust is gaining popularity, especially in systems programming, WebAssembly, and areas where memory safety is crucial. It has a growing and enthusiastic community. C++ has been widely used in industry for decades and has an extensive user base. Many large-scale systems and applications are built with C++, and it remains a crucial language in various domains. In summary, both Rust and C++ are powerful languages, and the choice between them depends on the specific needs of a project, the developer's expertise, and the desired trade-offs between performance, safety, and ease of development. Rust's focus on memory safety and concurrency makes it particularly appealing for certain use cases, while C++ continues to be a robust choice for a wide range of applications.